Imagine for a moment that time is not what we think it is. Imagine that humanity is not the first spark of intelligence to rise from the dust of Earth, but merely the latest. The rocks beneath our feet hold the memory of billions of years, but they are not a diary. They are a palimpsest, rewritten by oceans, volcanoes, and time. Civilizations rise and fall, mountains erode, continents shift, and ice grinds everything down to dust. In that endless cycle, how much could truly remain? What if our planet has been home not to one intelligent species, but many, separated by tens or even hundreds of millions of years? That is the question behind what scientists call the Silurian Hypothesis, the possibility that another advanced civilization existed on Earth long before humans, and that its traces are buried deep in geological time. The idea sounds like science fiction, but it was proposed seriously by two scientists from NASA and the University of Rochester. Gavin Schmidt, a climate scientist, and Adam Frank, an astrophysicist, asked a simple question in 2018. If an industrial civilization had existed on Earth long before us, would we be able to detect it? Could we even tell it had ever been here? Their conclusion was unsettling. We might not. The Earth is incredibly efficient at erasing its past. The surface of our planet is not static. It is alive with motion. Every 200 million years or so, the continents rearrange themselves completely. New crust is born at ocean ridges, while old crust is pulled back into the mantle, melted and recycled. The ocean floor itself is no older than 180 million years. That means that if a civilization existed before the time of the dinosaurs, all of its cities, its monuments, even its continents would now be gone, subducted into the depths of the planet. The only possible clues would be chemical and isotopic traces left behind in rocks that have somehow survived. The Silurian Hypothesis takes its name from the Silurian period, roughly 443 to 419 million years ago, when Earth's oceans teemed with early life but land was still mostly barren. The term is borrowed from science fiction. The Silurians were a race of intelligent reptilian beings in a 1970 episode of Doctor Who lived on Earth long before humans. But the real hypothesis is not about aliens or reptiles. It is about us. It is about what evidence our civilization would leave behind if it vanished today, and whether any future species, say 50 million years from now, would find it. If our entire civilization ended tomorrow, what would remain after tens of millions of years? Buildings would crumble, cars and machines would rust, and all organic material would decay. Even the great monuments, the pyramids, Mount Rushmore, the Great Wall, would be erased by erosion and tectonic shifts. Within a few 100,000 years, almost every visible trace of our existence would be gone. What would survive would be chemical signatures, plastic polymers, concentrated metals, and isotopic anomalies left by industry, mining, and nuclear technology. These would be locked into sediments, forming a thin, distinctive layer in Earth's geological record. In fact, geologists already call this the Anthropocene, the new epoch marked by human activity. Now imagine a civilization that lived, not thousands, but millions of years ago. Its entire layer in the rock record would have been compressed, tilted, or destroyed by geological processes. If we struggle to find fossils from the age of dinosaurs, how could we find traces of something from even earlier? The odds seem almost impossible, but not entirely. There are, after all, strange clues in the geological record that we cannot fully explain. In several layers of ancient rock, scientists have found sudden spikes in carbon isotopes, chemical signatures that suggest rapid global warming events similar to the one humanity is currently causing. One of these, known as the Paleocene-Eocene thermal maximum, occurred about 56 million years ago. During this period, the planet's temperature rose by up to 8 degrees Celsius in a geological instant. The cause remains uncertain. Some theories point to volcanic activity or methane release, but none explain the rapidity of the event. Could it have been the footprint of an ancient industrial civilization, one that burned through its planet's resources just as we are now? Schmidt and Frank did not claim that such a civilization existed, but they asked the question, would we recognize its traces if it had? Their answer was sobering. Most of the signs of an advanced civilization, metals, cities, artifacts, would vanish. What might remain are global patterns, spikes in carbon, nitrogen, or heavy metals, synthetic molecules like plastics, or isotopic ratios altered by industrial processes. These could persist in the rocks for tens of millions of years, but even they would eventually fade. Earth erases, Earth forgets. It is difficult for us to grasp how deep time really is. Humans have been around for roughly 300,000 years. Civilization, cities, writing, agriculture is less than 10,000 years old, but the Earth is 4.5 billion years old. If the history of the planet were compressed into a single day, human civilization would appear in the final second before midnight. Entire eras could have risen and fallen in the hours before that second, and we would never know. The rocks remember only fragments. Consider the fossil record. It is astonishingly incomplete. Most life forms that have ever lived left no trace at all. Fossilization requires a precise combination of circumstances: rapid burial, mineralization, and protection from erosion. Even then, over geological time, tectonic forces destroy the evidence. Less than 1% of all species are known from fossils. If a global civilization had existed millions of years before us, the chance of finding even a single recognizable artifact would be vanishingly small. Yet, there are peculiar anomalies that make scientists wonder. Metallic spheres found in ancient strata in South Africa, perfectly balanced and grooved, were once claimed to be artificial, though most now believe they are natural mineral formations. In coal seams and sedimentary rock, there have been occasional reports of what seem like worked metals, nails, or tools. Most of these are explained as geological coincidences or contamination, but they fuel curiosity. What if just one of them was real? What if we are looking at remnants not of myth, but of memory, forgotten by Earth itself? The Silurian Hypothesis does not claim that ancient civilizations built cities or flew machines. It asks a deeper, more unsettling question. How would we know if they did? The Earth's geological processes act as both creator and destroyer. The crust records everything, but it also recycles everything. In just a few million years, the surface of the planet can change beyond recognition. Even entire mountain ranges can rise and vanish. Our own technological civilization has altered the planet in profound ways. We have changed the chemistry of the atmosphere, the temperature of the oceans, and the composition of the soil. We have left behind synthetic compounds, plastics, fertilizers, industrial chemicals that will persist for millennia. If future geologists were to study the rocks of today, they would see a thin but distinct boundary layer marking the presence of intelligent life. But as Schmidt and Frank pointed out, even this clear signal would likely vanish over tens of millions of years. The next intelligent species might find nothing at all. It is a humbling realization. We think of ourselves as permanent, as the pinnacle of evolution. But in geological terms, we are temporary. Every civilization leaves a trace, but none lasts forever. Even our digital records, our art, our monuments, all of it will fade into dust. 1,000,000 years from now, the planet will still be here, but it will not remember us. And so the question remains, if Earth can forget us, could it have forgotten others? Could there have been civilizations that thrived and vanished long before the dinosaurs, or even before multicellular life became dominant? Could intelligent life have evolved more than once on this planet, separated by vast gulfs of time? The hypothesis does not insist it happened. It merely reminds us that it could have. As we peer deeper into the Earth's layers, we are reading a story written in rock. But most of the pages are missing, torn out by time. We see hints of strange events, mass extinctions, sudden shifts in climate, mysterious chemical signatures, but not their causes. Some of those events might have been natural. Others, perhaps not. The truth is, we don't know. The geological record is not a photograph. It is a mosaic of fragments. Between those fragments lies the space for imagination and for possibility. If a civilization once lived here millions of years ago, it would be gone beyond recognition. Its cities would have become sediment. Its satellites would have fallen, its metal corroded, its bones ground to dust. And yet, perhaps something remains. Not an artifact, but a pattern, a fingerprint in the chemistry of ancient rock, a subtle clue left in the air or ocean of another time. We are just beginning to learn how to read those traces. In the end, the Silurian Hypothesis is not a story about ancient beings or lost empires. It is a story about humility. It asks us to see our place in the vast history of Earth, not as the beginning of intelligence, but as one more chapter in a book too old for us to read completely. The rocks beneath us are deep and patient, and they have seen things we cannot imagine. Somewhere in those layers, perhaps, lies the faint echo of another civilization, erased by time, but not forgotten by the planet that bore it. The Earth hides its secrets well, but sometimes, even in its silence, it whispers. If the Earth had once hosted another civilization, what would be left of it now? Not cities or monuments. Those are far too fragile. Stone erodes, metal rusts, and even the tallest buildings would crumble under the relentless grinding of wind, water, and tectonic movement. What might remain would be invisible to the naked eye, buried deep within the planet's ancient memory, hidden in the chemistry of rock and air. To find it, we would have to look not for ruins, but for fingerprints, subtle signatures written in the elements themselves. Scientists have long studied the layers of the Earth as if reading pages in a history book. Each stratum tells a story of changing climates, of extinctions and rebirths, of the endless pulse of evolution. If there was ever a civilization before ours, its legacy would have to be hidden somewhere within those pages. But unlike bones or fossils, technological civilizations leave different kinds of traces. They alter the balance of the atmosphere, the chemistry of the oceans, and the distribution of metals in the crust. They leave isotopic scars that nature alone does not make. These are the signs we might one day find, if we learn how to look for them. The most obvious clue would be carbon. Our own civilization has changed the planet's carbon cycle in less than 2 centuries. The burning of fossil fuels releases massive amounts of carbon dioxide into the atmosphere, shifting the ratio between the heavier and lighter isotopes of carbon. This fingerprint will be locked into future sediments for millions of years. The same is true for nitrogen, affected by industrial fertilizer use, and for countless other elements. A future civilization studying our rocks might find a sudden, unnatural spike, a global marker of a technological species. If such changes appear in the geological past, we might interpret them as natural events. For example, the Paleocene-Eocene thermal maximum 56 million years ago shows evidence of a rapid carbon release and dramatic warming, eerily similar to what we are experiencing today. No volcanic activity can fully explain how quickly it happened. Could that event have been the work of another species, one that industrialized, burned through its energy sources and vanished? The hypothesis is not proof. It is a question, but the question itself is unsettling. If they existed, they may have made the same mistakes we are making now. Beyond carbon, there are other signatures that would outlast any civilization's monuments. Plastics, for example, are nearly indestructible on geological timescales. Over millions of years, they might break down into microplastics, spreading through sediments and even fossilizing within rocks. These synthetic polymers do not exist in nature. Their presence would be unmistakable to a future geologist. Already, we are creating plastiglomerates, stones fused with melted plastic, new materials that will endure long after our species is gone. Then there are heavy metals. Industrial mining, electronics, and manufacturing concentrate rare elements like lead, chromium, and platinum in ways that nature never does. If an ancient civilization once exploited metals, traces of unusual concentrations might still linger in old sediments. Our own activities have left a distinctive metallic fingerprint, a geochemical signal unlike any natural process. It would take tens of millions of years for tectonic forces to erase it completely. Another signature could be found in isotopes left behind by nuclear activity. The detonation of nuclear weapons, or even long-term nuclear energy production, changes the abundance of certain radioactive elements. Isotopes like plutonium-244 or cesium-135 do not occur naturally in measurable amounts on Earth, yet they would remain detectable in geological layers for tens of millions of years. If another civilization ever harnessed nuclear power or destroyed itself in atomic fire, the evidence might still be buried deep below us. Even global warming itself could serve as a marker. A civilization capable of altering its climate on a planetary scale, whether intentionally or not, would leave behind a chemical record. Higher temperatures accelerate weathering, change ocean acidity, and alter the ratio of oxygen isotopes in ice and sediment. So those signals endure far longer than any building or artifact. When we look back through Earth's history, we find multiple warming and cooling events, some sudden and mysterious. It is possible, though not provable, that one of them bears the mark of a species we will never meet. One of the most striking aspects of the Silurian hypothesis is that it doesn't require evidence of tools or cities to be taken seriously. The absence of artifacts is expected. The Earth recycles its crust so efficiently that even the continents themselves are temporary. After a few 100 million years, the surface is entirely renewed. The question is not why we haven't found ancient machines. It's whether we've misunderstood the clues that nature has already preserved. Some scientists have proposed searching for anomalies in the deep ocean. The seafloor collects sediments at a steady pace, layer upon layer, for tens of millions of years. Unlike the land, much of it is undisturbed by erosion or tectonic activity. Buried there could be chemical signatures of events that we have not yet recognized. Advanced sonar and drilling technologies could, in theory, detect subtle patterns, spikes in metals, plastics, or isotopes that might indicate industrial activity in Earth's distant past. Another place to look is the fossil record itself. Life reflects the environment in which it exists. A sudden and unexplained change in the ratio of elements within fossils, like a shift in carbon or oxygen isotopes, could indicate a global disturbance. In our own time, the burning of fossil fuels has already altered the composition of marine shells and corals. If such changes appear in older fossils without any clear geological cause, they might represent echoes of an ancient civilization's impact. But how likely is it that intelligence arose before humans? Evolution is not a straight line, but a branching tree with countless dead ends. Complex life has existed for more than 500 million years. During that time, species have repeatedly evolved traits like tool use, social behavior, and problem solving. Octopuses, crows, and dolphins show remarkable intelligence even today. It's not unreasonable to imagine that, under different conditions, one of these branches could have developed technology long before primates existed. Consider the time after the Permian extinction, 252 million years ago, when more than 90% of life on Earth vanished. The world that followed was nearly empty, full of opportunity. It took tens of millions of years for ecosystems to recover, but new forms of reptiles, amphibians, and early mammals emerged. Could one of those lineages have evolved intelligence, flourished for a few million years, and then been wiped out by another catastrophe? The fossil record would show only the extinction, not the civilization that came before. It's also possible that intelligence evolved in environments less likely to fossilize, coastal areas, rainforests, or islands that later sank beneath the sea. Most of the Earth's surface from that time is gone, subducted into the mantle. Even if vast cities once stood there, the continents themselves have vanished. Our ability to look back is limited to fragments of rock and mineral, tiny glimpses through the fog of time. When the Silurian Hypothesis was first introduced, it was not meant as a claim, but as a thought experiment, a mirror held up to humanity. It asks us how we would appear to future archaeologists millions of years from now. Would they see us as a blip in the record? A sudden burst of activity followed by silence? Would they even know we had existed? The unsettling answer is that they might not. The Earth is not a museum. It is a living, breathing system that erases its past as it creates its future. But even if ancient civilizations left no artifacts, they might have left consequences. Our own industrial age has already reshaped the biosphere. We are causing one of the fastest mass extinctions in geological history. If a previous civilization did the same, its ecological disruption could show up as a sudden loss of species in the fossil record, or as a layer rich in certain elements. There are indeed several mysterious extinction events that defy easy explanation. Sudden, widespread die-offs without clear volcanic or asteroid triggers. Could those have been self-inflicted? Could intelligence, wherever and whenever it arises, always carry the seeds of its own destruction? The Silurian hypothesis forces us to confront this possibility. It suggests that we might not just be studying the history of Earth, but repeating it. If others came before us, their silence may be the warning they left behind. And yet, perhaps the most haunting thought of all is that the Earth might hold their memory even now, encoded in its chemistry, invisible but real. Every rock, every layer of sediment is a time capsule waiting to be opened. Somewhere in those stones, there may lie an answer to a question older than humanity itself. Were we the first, or simply the latest? The search for that answer continues. Scientists drill into the seafloor, analyze ancient cores, and measure isotope ratios, looking for the faintest irregularities. Each anomaly raises new questions. Each unexplained signal is a potential whisper from a forgotten age. Whether natural or artificial, these traces remind us that we are part of a planet with a memory deeper than our imagination. If there were civilizations before us, their remains are not ruins but records, chemical, geological, planetary. They are the faint fingerprints of intelligence, erased yet eternal. Somewhere beneath our feet, written in the minerals of the earth, may lie the story of those who came before, and the story of what we too will one day become. If civilizations have risen and fallen before us, the traces of their existence would now lie buried deep beneath our feet, compressed into stone, diluted in the oceans, or scattered as isotopic ghosts in ancient air. They would be invisible to the human eye, but woven into the fabric of the earth itself. The Silurian hypothesis is not just about what might have been, it is about what always is. It is a reflection on time, on memory, and on the inevitable silence that follows every age of brilliance. Every civilization, no matter how advanced, leaves behind a planetary fingerprint. For ours, that fingerprint is already clear. We have altered the atmosphere, changed the chemistry of the oceans, and transformed the surface of the planet more than any species before us. We have released radioactive isotopes that will persist for millions of years. We have created synthetic materials that will outlive us by epochs. We have accelerated the extinction of countless species, reshaping the evolutionary trajectory of life itself. These are not simply consequences, they are our geological legacy. Millions of years from now, they will mark the brief, bright flare of our existence in Earth's history. If another civilization once lived here, its fate may have been similar. It may have risen through curiosity and innovation, spread across the planet, and unlocked forces it could not control. Perhaps it mastered energy, technology, and the environment, only to destabilize its own foundation. Climate shifts, resource exhaustion, or a planetary catastrophe, natural or self-inflicted, could have erased it entirely. If that happened, then its remains are not relics but patterns, erased and rewritten over deep time. What survives of a civilization is not its monuments, but its mistakes. There is a paradox in deep history. The more advanced a species becomes, the less trace it may leave behind. Primitive life fossilizes easily, bones, shells, impressions in stone. But the synthetic and the digital, the hallmarks of intelligence, dissolve into nothing over long enough timescales. The smarter a civilization is, the more completely it can disappear. Or then, perhaps that is the final lesson of the Silurian hypothesis. Progress leads to invisibility. To truly understand what might have come before us, we must think like geologists and historians of worlds. Imagine that it is 100 million years from now. The continents have drifted, new mountains have risen, new oceans have opened. The place where New York once stood is gone, buried under miles of sediment or swallowed by the sea. A future species perhaps as intelligent as we are, or more so, has evolved. They begin to explore their planet's history, drilling cores, measuring isotopes, studying the deep layers of rock. They find evidence of a strange period, a geological instant when carbon levels spiked, metals became concentrated, and synthetic molecules appeared in the sediments. They might see it as a natural anomaly, a sudden warming caused by volcanoes or meteor impacts. Or perhaps one of them will ask a different question. What if this was not nature but civilization? What if we are not the first? The same question now echoes in our own scientific community. Researchers are starting to think of planetary archaeology as a real field, analyzing not just Earth, but other planets for signs of past industrial activity. Mars, for example, once had rivers, lakes, and an atmosphere capable of supporting life. If Mars ever hosted intelligent beings, their traces would likely be chemical, not architectural. Perhaps changes in isotopic ratios or the presence of compounds that cannot form naturally. Venus, too, might hold clues. Its current hellish surface could be the result of a runaway greenhouse effect, one that some speculate could have been triggered by an earlier technological species. The search for ancient civilizations, then, is not confined to Earth. It extends to the stars. When we look for extraterrestrial intelligence, we are searching for ourselves, for the same signatures we would leave behind. Altered atmospheres, strange chemicals, energy emissions that defy natural explanation. Perhaps what we find out there will mirror what lies hidden beneath us. The universe may be full of civilizations that rose, changed their worlds, and vanished, leaving behind only whispers in the data, anomalies that no one can explain. This realization changes how we see time. Civilization may not be a unique event, but a repeating pattern. Intelligence might emerge wherever conditions allow, rise rapidly, and then disappear, leaving behind only traces that future species will puzzle over. In this view, the cosmos is not empty but haunted by the memories of countless civilizations that lived, dreamed, and died long before we existed. If that is true, then our story is not the first, and it will not be the last. But there is another possibility, one even more unsettling. What if the previous civilizations never truly vanished? What if instead they transcended physical existence? A species that mastered energy and matter could theoretically upload its consciousness into machines or quantum substrates. Over millions of years, such an intelligence might merge with the planet itself, becoming part of its processes. It might exist as patterns in the magnetic field, as quantum fluctuations, or as self-replicating nanostructures that mimic natural minerals. If so, we would never recognize it. We might be walking across the remains, or even the living form, of an ancient distributed intelligence. Some scientists have wondered if the Earth itself behaves like a self-regulating organism, the Gaia hypothesis. Life influences the climate, the atmosphere, and the chemistry of the planet to maintain conditions suitable for its survival. Could this be the unconscious continuation of an ancient design? Could life on Earth, in all its forms, be the long echo of a civilization that embedded its legacy into biology itself? The genetic code is a language, after all, a set of instructions that replicate and evolve. What if, hidden deep within the DNA of every living thing, there lies a message, not from gods or aliens, but from predecessors who found a way to survive the collapse of their world by becoming one with it? We cannot know, but the question itself expands our understanding of what civilization means. Intelligence may not always look like us, or build like us, or even think like us. It may not rely on metal or machines. It could exist in forms we cannot yet imagine, networked organisms, conscious ecosystems, or even patterns of energy and magnetism. If such a civilization once existed on Earth, it may still be here, not as ruins, but as a principle, embedded in the evolution of the planet, guiding life toward awareness again and again. And what about us? The Silurian Hypothesis forces us to face the uncomfortable truth that our time, too, is temporary. We are the first civilization we know of, but perhaps not the first that was. Our technologies, our cities, even our species will fade. The planet will reclaim everything, but what we choose to leave behind, our chemistry, our carbon, our waste, our wisdom, will become part of the next chapter. Somewhere millions of years from now, another species may uncover the faint traces of humanity and ask the same question we are asking now. Who were they? How did they live? What destroyed them? There is something profoundly humbling in this thought. We are not the masters of Earth. We are its momentary expression. The rocks beneath us are older than every word we have spoken, every empire we have built, every dream we have dreamed. To them, our entire history is an instant, a spark that'll soon cool. And yet, that spark matters. Because in that brief flare of awareness, we have begun to look back, to question, to seek meaning in the silence of time. If the Earth has harbored other civilizations before, then perhaps their legacy is not lost but alive in us. Every discovery, every thought, every moment of wonder may be a continuation of the same cosmic instinct: to know, to create, to endure. We are part of the same story that began billions of years ago when the first molecule learned to copy itself. The Silurian Hypothesis does not diminish humanity. It connects us to eternity. Perhaps someday, far in the future, when our own traces are buried and forgotten, another intelligence will walk this planet. It will study the rocks, the atmosphere, the chemistry of the deep Earth. It will find a thin, strange layer, rich in carbon, plastic, and metal, and wonder who we were. It will look to the stars as we do now and ask the same haunting question: were we ever alone? The answer may already be beneath our feet.